Well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 103 is on the screen, and if you grab a handout, it should be in there. Shouldn't take you long. Once again, today we're moving on, and we have a lot to cover, so let's do this. Brutus, give you guys some time for that, and go. All right, for the sake of time, here goes number one. It says graph, making a table with a domain from -4 to 4. All right, and we're substituting into the function 1 over blank, so this would be -1/4, -1/3, -1/2, -1, undefined, 1, 1/2, 1/3, 1/4. All right, here goes a graph. -4, 1/4. -4, -1/4 is about right here. -3, 1/3 on the negative side. -2, -1/2. -1, -1. There's that side, and we got 1, 1. 2, 1/2, 3, 1/3, and 4, 1/4. And as you can see, it starts curving a little bit more the more values we add to x. All right, go to number 2. Graph f of x equals x cubed. Now, I do want to go over this one a little bit more in detail because we're about to get into more transformations. All right, so our parent function is at 0, 0, 1, 1, -1, -1, -2, 2, 8, and -2, -8. So those 5 points. Pause the music. All right, so what happens with this value of a? Yeah, it's a whole number. It's going to stretch, right? So what does that mean with these points? Well, 0, 0 always stays at 0, 0. But 1, 1 becomes 1, 3. 1, 3. That means -1, -1 becomes -1, -3. So 2, 8 becomes 2. What is 3 times 8? 24, way over here. And the same thing for -2, 8 becomes -2, -24, somewhere over there. That's why it stretches like so. And then from there we move it what? 7 to the left and 4 up. 7 to the left, 4 up. So it's going to be a stretched cubic somewhere over there. So we move this one to there. All right. And don't forget to put the little exponent of 3 there. Let's go to number 3. Factor. Is there a GCF? No. Group by 2's. GCF here is x squared. We're left with x plus 4. GCF here is -1. We're left with x plus 4. What's the same here and here? X plus 4. And we're left with x squared minus 1. But wait a minute. What is x squared minus 1? Oh, square root of the first. Square root of the last. 1 positive, 1 negative, and bring down the x plus 4. I left you guys some of that on that home play 2 days ago. All right, let's go to this one. That's 10, 11. Factors of 10 that add up to 11 is 10 and 1. But we have a coefficient of 5. 5 here and 5 there. Can we simplify this fraction anymore? Yeah, divide by 5, so it's 1 over 2. So my factor is x plus 2. Can I simplify that one anymore? 5 over 1? No. So it's 5x plus 1. Oh, yeah, we got this, Enrique. All right, let's go to number 4. It says synthetic division. Let's see, standard form. Third degree, first degree, 0 degree. We're missing the second degree. First degree, 0 degree, yes. Set it equal to 0, divide by 3. X equals negative 3. My divisor is negative 3. All right. So my coefficient for the third degree is 2. For second degree is 0. For first degree is negative 1. For 0 degree is 3. Bring down the 2. Negative 3 times 2 is negative 6. Combined, that's negative 6. Negative 3 times negative 6 is 18. Combined, that's 17. Negative 3 times 17, that's negative 51. Combined, that's negative 48. And if we started with a cubic, that means this is 2x squared minus 6x plus 17. But we have a remainder, yes, of negative 48 over x plus 3. How we doing? How we doing? Good? Yes, Mr. Q. I love these. All right, because you're going to get some more today. Let's go. And number 5, solve the equation. Set it equal to 0, x squared plus 4x minus 5. Factor, negative 5 and positive 4. What two factors of negative 5 add up to positive 4? That's 5 and negative 1. So my factors are x plus 5. X minus 1, all that equal to 0. Set each one equal to 0. Solve. So therefore, minus 5 minus 5, x equals negative 5, plus 1, x equals 1. These are my solutions. X-intercepts, roots, or as we call them now, the zeros. All right? The agenda for today is warm-up 103. I wrote it on top of that handout, polynomial equations and zeros. Tonight's home play is 4-factor and graph polynomial equations. Copy this code, please, DNWL6. DNWL6. That's to access the home play for tonight. Last night's home play were 8 graphs, so go to Canvas, turn that in right now, please. 8 graphs. And tonight's home play is this one. Once again, if Nearpod is having issues, go to the YouTube channel. It should come up there on the screen. Only 4 problems. All right. And the equation, the objective for today, I can identify and graph rational zeros of polynomial equations. You can write the objective at the bottom left of that handout or somewhere at the top. That's fine. I'll give you guys some time to turn in your home play. Go. All right. All right, here we go. Well, we don't need our Chromebooks for this one because it's going to be packed with stuff. So, once again, we're still in the middle of polynomial equations, but today we're identifying and graphing our rational zeros. So, we know what polynomials are for polynomial equations. We have the notes on that. That's what they look like. That's what we've been working with. And our roadmap for what we did this week, I gave you guys practice for synthetic division and factoring. Is that correct? On Monday? Yes. Tuesday we came back. We talked about zeros and rationals. And then I gave you guys the rational zero theorem, and you had some home play given this, where you needed to make a fraction and then find all the possible factors. Is that correct? We did some of those in class. You did some of those for home play. Then we came back the following day, and I said, all right, guys, get this table done. We filled it in. Remind your neighbor what is so special of all that. Remind them, what did we learn from that table, please? What did we learn from that table? Tell your neighbor, please. All right, what did we learn from that table? Let's see, who haven't we called on in a while? How about Caesar? What did we learn from that table? I heard start at 3 and end in 1. What? The odd number exponents. That is correct. Odd number exponents of the functions start at quadrant 3 and end in 1. And what else? And the even number exponent functions start at 2 and end in 1. That is correct. That's why we are able to just draw our arrows and then finish off with our zeros. Okay. Then we did some of these, this, that, and the other. Is that correct? Well, we arrived today to put all the puzzle together. Y'all ready? The whole thing. Y'all ready? All right, here we go. Example number 1. It's on your paper. Here we go. So according to what we did the other day, however, this is a simple one. We're not going to start with our fraction, but on this one, set it equal to 0, because it needs to be in factored form. Is that correct? Yes, Mr. Q. Very simple one. Can we factor that? Yes. We got negative 20, and we got negative 1 for this coefficient right here. What factors of negative 20 give us the sum of negative 1? Tell your neighbor. Jesus. Negative 5 and 4. So my factors are x minus 5, x plus 4, and all that equal to 0. What was the next step from what we did yesterday, guys? Set them equal to 0. Solve. And these are my zeros. Question, how many x's do we have? 2. Where do they come from? From x squared. So tell your neighbor where the arrow starts and where does it end. Where do we start? Where do we end on the graph? Renzo, where do we start? Where do we end? Top left and end. That is correct. So we plot our zeros. Our zeros are negative 4, positive 5. Start with the first arrow on the left. Connect to the other. Going through the zeros. From 1 to 5, come to where you with that. We got it, right? 5 4 is 5 4. Let's go to the next one. Example 1Q. Once again, they give us, it looks kind of similar to the one we did. However, this is what I want you to do. Set it equal to 0 to get started with. Next, it needs to be in factored form. Is that correct? So before we move on to, can't use the Power Rangers because it's the cubic, but can we check for GCF? Tell your neighbor what GCF would be for this. What would be GCF? What's GCF? Renzo, pass on one. Joseph, what's the GCF? X. And that leaves us with x squared plus 4x plus 4, and all that equal to 0. Can we still factor that trinomial? Yes. 4 Factors of 4 that add up to 4. Pass on one. Mario. 2 and bam, Mario. X plus 2. X plus 2. Bring down the x equal to 0. Next step. Pass on one, Mario. Mariah, what do I do next? X equal to 0, x plus 2 equal to 0, and x plus 2 equal to 0. That is correct. All the factors equal to 0. This one's already solved. This one minus 2, x equals negative 2, minus 2, x equals negative 2. And I'll give you a head start for the graph. Go. All right, good head start. So if you look at it, these are our zeros. How many x's do you see, everyone? 1, 2, 3. So it comes from what? F of x equals x cubed, the parent function. So where do we start and where do we end, Sammy? Three and 1. So 3 and 1. And then we put our zeros there. We got x equals 0 right in the center. X equals negative 2. But there's 2 of them. Remind your neighbor what to do with that, please, just in case he missed it. What do you do with that? All right, so I start with the arrow farthest to the left, and then bounce, and then through. Hands, you got something like that? Yeah, let's do this. Let's go. Oh, yeah, we got this. Go to the next one, example 1 super cube. And if you notice, it's starting to get a little bit more intricate. So first things first, check this out. Before we, let's set it equal to 0. X cubed plus 5x squared minus 17x minus 21. Question, is this a trinomial? No, not anymore, Mr. Q. All right. Is there a GCF, everyone? No. So at this point, we use the rational zeros theorem. So we make a fraction. Remind your neighbor, what numbers are we going to use from that equation to make our fraction? What numbers are we going to use to make our fraction? Pass someone, Sammy. Jesus, what numbers? Negative 21, which is a constant, over an invisible 1. That is correct. So therefore, factors of 21 are 1 times 21 and 3 times 7. Those are all our factors. For 1 is just 1. Therefore, plus minus, 1 divided by 1 is 1, 3 divided by 1 is 3, 7 divided by 1 is 7, 21 divided by 1 is 21. All right, everybody remembers what to do now? Yes? So let's start with positive 1. Let's check positive 1. And then we're going to use all our coefficients. We got 1 here, 5, negative 17, and negative 21. Bring down the 1. 1 times 1 is 1. Combine that 6. 1 times 6 is 6. Combine that negative 11. 1 times negative 11, that's negative 11. That's negative 32. And that is not our 0. What do we try next? Negative 1. Negative 1. Negative 1 times 1 is negative 1. Combine, that's 4. Negative 1 times 4 is negative 4. Combine, that's negative 21. Negative 1 times negative 21 is positive 21. And that is our what? Our 0. So, remind your neighbor how to write this in non-sine synthetic form. How do we write this? So circle it. Draw an arrow because we're going to write it over here to the side. How do we write that one? Let's see if you remember. Let's go with Elijah. How do we write that in non-synthetic form? Parentheses. X plus 1. That is correct. And what do we have left, everyone? We started with a cubic. That means this is what? X squared. What else? 4x. What else? Minus 21. I'm going to write it here next to this one. X squared plus 4x minus 21. And all that equal to 0. Question, can we factor this one anymore? Yes, Mr. Q. Negative 21. Positive 4. What two numbers multiplied give me negative 21? When you add them, give us positive 4. Tell your neighbor, and then Elijah's going to pass them one. Elijah, pass him one. Joseph. Seven and negative 3. So my factors are x plus 7, x minus 3. Bring down the x plus 1, and all that equal to 0. Tell your neighbor what's the next step before we go graphing. What do we do next? Pass on, Joseph. Mario, what do I do next? X plus 1 equals 0. Plus 7 equals 0. X minus 3 equals to 0. Let's solve. Minus 1, x equals negative 1. Minus 7, x equals negative 7. Plus 3, x equals 3. And how many zeros do we have? 1, 2, 3. That comes from where? F of x equals x cubed. So, where do we start in our graph and where do we end? Pass them one. Enrique. Where? 1, 2, 3, or 4? The third one. All right, so arrow over here, and it ends at 1. Okay. So, negative 1, negative 7, 3, from left to right, show your neighbor your graph, see if they have something similar to yours, help them out if they made a mistake. All right, from 1 to 5, how come through are you now putting it all together on this one? 5 4s, 5 4s, yes. All right, let's go to the next one. Example super duper Q. We got f of x equals x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24. Set it equal to 0. And tell your neighbor the fraction you're going to write. And then Ashwin's going to enlighten us with the fraction. Go ahead, Mario. All right, good conversations. Ashlyn, what do I write for our fraction? (24/1), that is correct. And factors of 24 are, hold on, I start with 1. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Therefore, we're going to be checking all these numbers. 1, 2, 3, 4, 6, 8, 12, 24. Well, actually, we're not going to check all of them, but we're going to start with some of those. All right. So, we're starting with positive 1. Our coefficients are 1, negative 4, negative 7, 22, and 24. 1 times 1 is 1, that's negative 3. 1 times negative 3 is negative 10. 1 times negative 10 is negative 10. Combined, that's 12. 1 times 12 is 12. Combined, that's 36. That is not our 0. Next, let's go with negative 1. Negative 1. 1, negative 4, negative 7, 22, 24. Negative 1 times 1 is negative 4. Combined, that's negative 5. Negative 1 times negative 5 is 5. Combined, that's negative 2. 1 times negative 2 is negative, it's positive 2. That's 24. And negative 1 times 24 is negative 24. That leaves us with 0. This is our first 0. So how do we write that in non-synthetic form? Pass someone, Ashlyn. Mariah, how do we write that in non-synthetic form? X plus 1, okay. And what do we have left? If we started with the 4th degree, what do we have now? X to the 3rd minus 5x squared minus 2x plus 24. So let me write it over here. X cubed minus 5x squared minus 2x plus 24. All right, so we still need to factor this one, so we need to make, what do we try next? The 2? Yes, that's a cube. All right, so positive 2. What is my coefficient here? 1, negative 5, negative 2, and 24. Here you go. 2 times 1 is 2. Combined, that's negative 3. 2 times negative 3 is negative 6. Combined, that's negative 8. 2 times negative 8 is negative 16. Combined, that's 8. This is not my 0. What do we try next? We already tried positive 2. Let's try negative 2. 1, negative 5, negative 2x plus 24, or positive 24. Why did I write the x there? Come on, Q. Get on the ball. 24. Bring down the first. Negative 2 times 1 is negative 2. That's negative 7. Negative 2 times negative 7 is 14. Combined, that's 12. Negative 2 times 12 is negative 24. And this is my other 0. So how do I write that in non-synthetic form? Pass someone, Mariah. Callie. X plus 2. X plus 2. Let me bring down the other one next to it to keep organized. X plus 1. X plus 2. And what do we have left over, everyone, if we started with a cubic on this one? We're left with x squared minus 7x plus 12. All this equal to 0. Question, can we still factor this trinomial? Yes. What factors of 12 add up to negative 7? Tell your neighbor. What two numbers multiply give me positive 12 when you add them give us negative 7? Tell your neighbor. Pass on one, Kelly. Who? Caitlin. What is it? -3, -4. So my factors are x minus 3, x minus 4. Bring down the other ones, which are x plus 2 and x plus 1, and all that equal to 0. And of course the next step, x plus 1 equal to 0, x plus 2 equal to 0, x minus 3 equal to 0, and x minus 4 equal to 0. And for the sake of time, what is the first 0? X equals -1. The next one is x equals -2. The next one is x equals 3. And the last one is x equals 4. All right, let's graph that. And by the way, there's 4 of them, so it comes from what? From f of x equals x to the 4th. That means, where do we start, where do we end? Caitlin, pass them one. Joseph. We start at 2 and end at 1, and our zeros are -2, -1, 3, 4, something like that. Woo. All right, from 1 to 5, I'll come through argue with this. How we doing? 1 to 5. I got some 5s, some 4s, 5 4s. All right. So, question: do we need one more? Or are you guys ready for the home play? Yeah? All right. So I'm going to let you guys do the home play. Let me go back to that screen. There it is on the screen. Those of you following on YouTube, get some practice in. See you guys next time. Peace.